Thank you, Dr. Pares. Now, ladies and gentlemen, I'm really very excited and privileged to introduce our special guest of this e-conference, who has been the stalwart member of Department of Science and Technology, Government of India since 2015. He is the Secretary of Department of Science and Technology, that is DST, Government of India, as well as the Institute Chair Professor, former CV Seshadri Chair Professor, and Head of Chemical Engineering Department, IIT Kanpur. He is none other than Professor Ashutosh Sharma. Professor Sharma has served the governing bodies and councils of several prominent scientific institutions in India and has had a broad international experience as a research faculty. Professor Sharma is a recipient of numerous honors and awards, including the TWAS Science Prize, Bessel Research Award, J.C. Bose Fellowship, Santi Swarup Bhatnagar Prize, Homi Bhabha Award, Syed Hussein Zahir Medal of INSA, the Lifetime Achievement Award of Indian Science Congress, etc. He is an elected fellow of Indian National Science Academy, Indian Academy of Sciences, National Academy of Sciences, Indian National Academy of Engineering, the World Academy of Sciences, the Asia Pacific Academy of Materials, etc. Professor Sharma's research contributions are highly interdisciplinary, spanning a wide range in nanotechnology, health and environment, functional interfaces, colloid and interfacial engineering, biomaterials and biosurfaces, etc. And he has published over 300 peer-reviewed papers, filed over 10 patents. We, the Department of Chemistry of Ukkatarsaria University, is extremely honored to have Professor Ashutosh Sharma among us, and it's our extreme pleasure that he has agreed to give us some time from his extremely busy schedule. Thank you very much, sir, for being with us, and please share some words of wisdom with our participants. Sir, please.
Thank you, Sutapa. My remote namaste to everyone who has joined us. This is a great thing happening. I'm so happy that Paresh Patel has taken lead in initiative in holding this conference. This would be greatly beneficial to very large number of researchers.
Yes.
Maybe can you explain to all the participants the meaning of the name of your university, which is Ukkatarsaria? What does it
sure,
mean?
sir. Sir, Ukka is one person, grandfather of the person who had donated a huge amount of money for establishment of this university. And Tarsad is the foundation. I think Professor Paul might be knowing the same foundation is there in California. There are many mortal with Tarsadia group.
I see.
So, Ukka is the name of that grandfather of that donor, and Tarsad is a group of people who are working with this kind of NGOs.
So it's not a Gujarati name.
No.
Oh, that's what I thought. So I thought this looks very odd. Never seen this name before. Anyway, fantastic, and it's great that Professor Paul Weiss has joined us, has joined you. He is indeed the big champion of everything small. So it is our great fortune to have him here, as well as all the other distinguished speakers that would be joining you later. So I wish the conference all the very best. And this is a conference on frontiers in chemical sciences. That correct? You see, the frontiers of chemical science today, a whole lot of them are also frontiers of physical sciences. They're also frontiers of material sciences. They're also frontiers of biological sciences, and so on. So this world is today, the world of science is all about convergence. So while, chemical sciences is a good way to tell what we would be teaching in undergraduate education, it doesn't really describe what we do in research. So we must remember that going forward, all of us who have assembled here is not to take our label as chemical scientists very seriously, but to focus on problem solving. The problem solving, if you look at the challenges of today or going forward in the future, all those challenges are interdisciplinary. They are multidisciplinary. In fact, they are out of disciplinary. because a completely wrong way to say something is interdisciplinary, because we set up some disciplines first, and now we are arguing that this is interdisciplinary, but it's a problem to be solved. And that problem to be solved, it requires many different people. Our last 2 months experience, people made state of the art diagnostics despite all the constraints. Labs not working, people not there, supply lines not being there, and people were able to make state of the art diagnostics, even new methods, CRISPR car tool, and LAMP, beyond PCR, the standard PCR, but confirmatory test, and at the cost of one-tenth of what was available. And these are all going to hit the market in next week or two. There are new ventilators, in fact, new designs for ventilators which were not available in 10 years. I looked at this ventilator, which has IoT in it. So one doctor can monitor about 10 patients, because we have fewer doctors and more patients and ventilators. So if you put in some artificial intelligence, machine learning, so that you don't have to fiddle with knobs all the time. And also IoT allows this communication, between people and the machine, between the internet and the machine and monitoring. There's a group in artificial intelligence that we set up with some speed, and they are solving about half a dozen problems which are related to artificial intelligence and so on, diagnostics, therapy, everything. So the world is very interdisciplinary, and there are a couple of lessons in what we have learned, uh, both for the global science and certainly for Indian science. You see, in India, India produces a very large number of scientific papers. So we are number three in the world for number of publications in science and engineering. We also number three in publications in chemistry. But you see, it's not enough to have large number of publications. The challenges are to improve quality. We should all aim to publish in the journal, which is, edited by Paul Weiss, for example. We all know about the journal. So we should have good journals to publish in mind. But you will have good journals if work is not incremental. So we focus a lot on incremental work rather than profound work. And a whole lot of this happens because, we are following some group somewhere else and saying, hey, this is a hot topic, this is a great group. So I would do something similar, but doing something similar means that it's only incremental. So let's encourage people, let's encourage our students to take risk, even to fail. They don't need to produce 10 papers in their PhD, but which are like a filler material. But we should encourage people who can to do something more profound, something more relevant. So thinking about relevance, you see, it's very important that applied sciences should connect with industry early on, to get a right direction about what is needed really, uh, right? I'm not saying that the fundamental or basic research is not useful. It has a different purpose. In the fundamental or basic research, the emphasis has to be on quality. It has to be on the novelty of our thought, uh, right? It has to be a little bit disruptive, profound, not incremental. But when we look at applied sciences, it has to be applied. Okay, there's no point saying that it would be applied by someone, right? Then I've not really done my job. So to do that job, it has to be relevant, and it must connect with the startups, with industry, with. So I'm not saying only for money, but for socioeconomic good. And this is what the period of COVID-19 has shown us. How is it possible to do something new and also scale it up within 2 months? I mean, we could have done it 10 years ago. There's no reason why a good ventilator could not be made in India 10 years ago. but it's because there is a clear and present need, and everybody perceives that need, and everybody is working in a committed way to solve that problem. So if we have that in many areas of science, I have no doubt that things will become more exciting. They'll be far more fulfilling. So if you look at, you see, I think your conference is focusing on nano in medicine. Whole lot of papers I read on nano in medicine, they are of two kinds. They are either theranostics, so drug delivery, or multiple delivery, plus also diagnostics combined with it. And there are many combinations. The other is related to biomaterials. In both of these areas, if you just do the Google search, you would find several hundred thousands of papers. Not all of them are of equal interest because not all of them bring an insight, right? So a whole lot of them are related to permutation, combinations of materials, of drugs, of different platforms for the delivery and so on. Um, and it's very hard to translate any of them if ever in practice. So to my mind, I request all my younger colleagues here that when we do research, we look at least one of the two aspects. The first one is the quality. Does it have a new insight, or I'm just reading what everybody else has said, but with a different material, right? So there is no end to these permutation combinations. And if you look at photocatalysis, photoelectrocatalysis is a very good example of that. I was the other day, I did a Google search on graphene in photoelectrocatalysis. There are more than 150,000 papers just in graphene, more than 100,000 papers. So if you really look at them, what they're saying, they are saying, look, let's wrap something in graphene, or put something on graphene, and I'm done with one thing. Then I put two of them, then I put three of them. But there's no new insight in any of them, right? And they all not going to produce any superior result, right? So in terms of capacity or performance, they are similar to everything else. And that's expected because there is no new idea. In fact, also, if you look at many of these areas, you see that there is no standard protocol. So you see the photocatalysis. It's impossible to compare different studies. And none of them really has the true kinetics. So they cannot be scaled up. So they're just ignoring mass transfer, heat transfer, diffusion, porosity, the surface resistance, what have you, mixing, all of that. And so it is just at the particle size, the character size, what have you, right? So I've seen very few papers that relate.
Excuse me, sir.
Yeah.
I think there is your voice is little bit getting disturbed. Maybe some like
Yeah, it's
connectivity
not because of me.
internet.
It's not because I can't do anything about it.
Now it's
It's
clear,
not
buddy.
because
Now
of
it's
me.
clear.
It's because of the connection.
Okay, okay. Now
Oh,
it's
so
clear.
maybe my microphone was hidden. Oh, okay. Is that better?
Now it's fine. Now
Is
it's
that,
fine,
is
sir.
that okay?
Yes,
It's
yes, yes, yes.
fine.
Yes,
So
sir.
of course you don't want me to repeat everything I said.
Yeah,
Certainly
yeah.
not. No,
No, no, no.
it's not a threat. Okay, now I'm not going to do that. Okay, so I just conclude by saying that look, we have to look for one of the two things in our research, either the quality, new insights, and profoundness, or the relevance of that if it's applied work going forward. This is much harder. Me as a scientist, I can tell that this is very hard to do it because we as a scientist, while we have to attend conferences, we have to raise money for our research, we have to mentor our students, then we have to do some administrative work, then we have to teach, right? And so where is the time, insight, and energy now to actually look at these aspects, right? So it's a question of culture. I think if we raise our PhD students with a different culture, I think this would be possible. Now everybody has to be trained for academia. There's another weakness that I see in our universities. See, finally, less than 10% PhDs would find job in academia, right? So we put them, they are not factories for producing papers. I think let's understand that very clearly. They are not factories for producing papers for the mentor, right? They need to be trained in a meaningful way. And this is our shared responsibility to train them in a way so that they would find fruitful avenues of growth, not just in academia, not just in R&D labs, not just by government, but that they would actually produce new industries. They would not just be seeking a job, but would be, make jobs for others. This is a very special responsibility for all of us teachers, professors, mentors, and this has to happen. Going forward in the future, I would just conclude by saying, look, what are the challenges? These are sustainable development, huge challenges. We have never lived, the nations, we have never lived under constraints. So technology, we thought in the 1950s, 60s, we thought technology will solve all problems, that the growth would be without constraints, a very happy, very optimistic view of the world. But it may be a little bit different going forward in the future by the end of this century. So sustainable development, rise of intelligent machines, which, while humans in some way have to compete and collaborate with them, rise of antimicrobial resistance, handling and managing diversity, very important, right? And so this is, it doesn't look like problem of science and technology, but a lot of aspects of it are related to science and technology. Managing our demography, climate, resources, which is part of sustainable development, globalization. Now we are seeing examples of globalization here. So if you, Paresh, is not a good teacher, then you will be replaced by Professor Paul Weiss,
Yeah.
right? So because your university would offer him good money to give lectures.
Online
See, a
lectures.
remote lecture given by me and by XYZ is the same. It doesn't matter if I sit in India. It doesn't matter if I sit 10 kilometers away from you or if I sit 10,000 kilometers away from you.
Right.
So we need to shore up our quality. So for the challenge of globalization is not just doing this little incremental things, but
Mhm.
bring confidence in people that they can do great things. Look, they, your students, they don't lack intelligence,
Yeah.
they lack confidence.
Guidance, confidence.
So, do we have a special way to build their confidence? In India, it's very cultural. See, you know that when your son and daughter grows up, goes to college, and is getting, let's say, 98% in high school, you would be very unhappy. You would say, "Hey, my neighbor is getting 105%, right? You guys not, you are terrible." So it doesn't do anything for their confidence, right?
Yeah,
So
yeah.
you really have to bring out this fact that each one of these people are
Different.
capable of doing the best, right? And train them in such a way so that they can take risk, because taking
Yeah.
risk has to do with the confidence. It has nothing to do with intelligence. In fact, very intelligent people who have been successful following a recipe will never take risk. So we must encourage
Mm.
people to fail, right? And as a parent, as a teacher, little bit of our responsibility to encourage people to take risk,
This.
which is a good risk, not a stupid risk. I'm
Yeah.
not saying drive recklessly, okay? I'm not saying anarchy. I'm saying take good, reasonable, logical risk, and maybe you fail, which is okay, right? But then you would have learned something, and certainly you would do great things later
Yes.
on, right? So thank you very much indeed. I took longer than I
Oh,
thought I would. I'm so thankful to everybody here, and I wish everybody a great day and great research and teaching going forward in their lives. Thank you very
thank
much. Namaskar.
thank you
Thank
so very
you.
much, sir. Thank you so,